Good morning, pilot teachers and students. Good morning, class.
Good morning.
All right, thank you. Okay, we are still on work, energy, and power. Right, the topic for today will be work. Now, let's have a look at the definition of Rachel. Can you define work?
Work is done when force moves an object over a distance.
Okay, so scientifically, we can simply say work is done when an object or force moves through a distance. Now, this is in everyday life we can use that more, or in other words, it is commonly used. Now, last time I gave you one example, saying that if your friend is trying to push a car out of a mud, and then it's taking him whole day to push that, probably if you come along and tell him that you have done no work, but he has sweated all day just to get that car out, right? It will be quite offending to him because he has done work. So in other words, we can use this term to express in anything that we do, right? Especially if you are using sweat, that means you are doing work, and that energy comes from the respiring cells. Right, in here we'll be looking at the physical term, which is work. So from our definition given, okay, when a force moves through a distance, okay, that is the definition of a work. Or we can simply say when you apply force to an object and that object has to move through a distance, the work has been done. So I'd like you to quickly copy the definitions, right? But students, you can also have the definition down quickly. All right, moving on to work is done when a force moves, right? As the work is done, you would expect the amount of work done depend on the size of the force or simply the distance that object moved. If it has moved less distance, then probably you can say that less amount of work will be done, because work given from equation will be the product of force and distance. Okay, let's move on to the next slide. Okay, we can correctly say that the amount of work done is simply the product of force and distance. So given from that equation, work equals to force times distance. Okay, this is maybe confusing, but if you can see, the force is given by this letter F, and then you have S for the distance. Okay, that is generally on the equation. All right, that is the dimensional unit for force and also the SI unit. But in here you only find the SI units. Right, looking at each one of these in our grade 11, one of the unit that we studied earlier on measurements, you would know the different types of SI units. Right, using the force equals to mass times acceleration, and given from this we have this work which is given as force times distance, S. And if you are looking at this, mass times acceleration would be kilogram meters per second square. And if it is force times distance, our force would be taken from this one. So the distance would be this S. Right, so when this happens, and when you're given that, it will be a kilogram meters per second square. Okay, times S. All right, just have a look at this and then tell me what you can find in this equation. All right, this distance is in meters, so we take this one as kilogram per meter per second square for the acceleration or force and also the acceleration. And then when you take this, multiply that with distance, and that is the SI unit for work. Right, so you can also have a look at that unit and see that there is also Newton meter in there. All right, the force is measured in newtons and then distance is in meters. So that is why you were given as Newton meter, or one common unit that is used is simply the joule. Right, so copy the units for that, and then I will go on to giving you the exercises or activity questions. Questions, activity questions, and then you can discuss on those questions. I'll give you some time to discuss. Probably can come up with the answers to each one of these. Right? You will have to state whether work is done in each one of these. Okay, activity questions. In number one, you can see that in each situation you state whether work is done or no work is done. Right? Number one is a girl is holding a heavy weight. That is number one. Number two is a book is resting on the bench. Okay. Next question. You can see the difference between question 3 and 4. For third question is a weightlifter is lifting heavy weights, and then you have fourth question which reads a weightlifter is holding that weight above his head. And question number 5, if you are working or walking to the nearest store, you have to state whether work is done in that situation. And this, you and Joseph will do question 1 and 2. Okay, that is for you. There. This is Nathaniel, Isaac, and Charlton. You do those last 3. Okay, decide which one to take. Okay, last 3 questions. Number 5. You. Number 3. Okay, you took question number 4. All right, when you. Okay, I'll give you time to discuss those questions, and then you state whether each situation work is done. Okay. Now after that, you will have to stand up. I will ask some students to stand up. Probably you can state whether work is done and then explain why you think that work is done or no work is done in that case. Okay, no work done. Okay, good. Okay. All right. All right. We will now go through the answers. All right. I will be asking each one of those students who were chosen to give you answers to each questions. Pilot students, please observe carefully as the model students will provide the answers to those questions. If you think that your answers are similar to his answer, probably you can give yourself a mark. All right, we'll start off with question number 1 for that is when a girl is holding a heavy weight. Jos.
Question number 1 states that a girl is holding a heavyweight object. She is holding the weight but not lifting them because she's not doing any work because the weights are not moving.
Okay, very good. The girl is just lifting. She's not lifting it, but she's holding it up. So you just imagine what will happen if you come across that girl. If she's holding that weight for almost an hour and you are telling that she has done no work. Okay, you know what will happen. Okay, that is for question number 1. No work is done. Moving on to question number 2 is a book is resting on the bench. Joseph?
In this situation, I concluded that no work is done. It is because, if we refer back to our notes copied earlier, work is done only when a force moves. And therefore, we can conclude that no work is done because it is obvious that the book is just resting on a table.
Okay, very good explanation. In that situation, you find that it has not moved a distance and it was just resting toward the bench. So that is why no work is done. All right, good. We will move on to question number 3.
For question 3, work is being done because the lifter exerts force to lift up the weight.
So you are saying that work is done. All right, good. Work is done in question and that situation number 3. Okay. So because he is lifting, we don't know how much distance that weight was lifted, but it is because it was taken from a certain place and then brought to a certain place, we can say that work is done in that case. Right, moving on to question number 4.
For question number 4, no work is done because an upward force is exerted, but no motion is up.
So no work is done.
No work is done.
Is that correct?
Yes,
Okay, good. The answer to that question number 4 is no work is done because he's just lifting, just holding the place that weight in one position. All right, last question.
For question number 5, work is done because walking is a force which moves through a distance.
Samuel, what do you think in that situation? Do you agree with Charlton? Okay, he's saying yes. All right, that is correct. Work is done in that because the person is moving himself from one point to the next, so work is done. All right, we have just looked at work, but there are some other categories of work, and we will also look at work in different perspective. Now, firstly, in everyday phenomena, we seem to use the term work. Okay, if you were writing in a classroom, you can say that you have done work. But if you have to look at that scientifically, probably in some cases it may mean work is done. But others, when you're trying to study physics and learn about physics, work is only done when you move an object through a distance. Okay, so the work done is simply the product of force and distance. Right, the SI unit of which this work will be in joule. Right, it's in joule, or it can be given other unit as well, that is Newton meters, and other SI units in dimension will be kilogram per meter square, or kilogram meter square per second square. Right, that is the lesson on work. I hope you have learned something. Now in our next lesson we'll be looking at different categories of work, right? Especially when you're trying to apply force at an ankle, right? You will have to see whether work is done in that case or work is not done. So that is what we'll be studying in our next lesson. Okay, that is the answer to our activity questions. And our key word would be? Okay, work. Okay, good afternoon, pilot teachers and students. Good afternoon, class. Good afternoon. Okay, we sit down.